Reasoning, mental ability and simple arithmetic, comprehensive lecture notes. Reasoning and mental ability test your capacity to process logical problems, patterns, and verbal intelligence, while simple arithmetic evaluates your foundational numerical skills. These areas are critical in the CAS preliminary examination because they measure decision-making under pressure, and the pattern over the years shows consistent weightage of 15 to 20% of the paper, often determining the cutoff. Verbal reasoning. Verbal reasoning questions assess your ability to understand and logically interpret written information. Key topics include analogies, classification, series, coding decoding, direction sense, blood relations, and logical deduction. Analogies involve identifying relationships between pairs of words, numbers, or figures. You must decode the logic connecting the first pair to correctly identify the second. Example: doctor, hospital, lawyer. The answer is court, because both professionals are associated with their workplaces. Classification questions ask you to identify the odd one out from a group. The key here is to quickly categorize the logic, be it semantic, numerical, or alphabetical. Series problems involve identifying the pattern in sequences. These can be alphabetic, numeric, or mixed. For example, in a numerical series like 2, 4, 8, 16, the pattern is multiplication by 2. Coding decoding involves substitution and rearrangement of letters or numbers using a defined or hidden logic. For instance, if in a certain code, mango is written as NZOHQ, what is the logic? Here, each letter is moved one step forward in the alphabet. Direction sense test involves scenarios where a person moves in a sequence of directions and you must determine their final position or direction. Always keep track using a mental or drawn map. Blood relations assess your ability to decode complex family trees based on descriptive statements. They test clarity of relational vocabulary like maternal uncle, niece, sister-in-law, etc. Practice diagramming the relations. Logical deduction includes syllogisms and statement conclusion type problems. For syllogisms, using Venn diagrams can simplify even the most complex argument chains. 2. Nonverbal reasoning. This involves pattern recognition, mirror and water images, embedded figures, and paper folding. Nonverbal reasoning checks your spatial visualization skills and often involves visual puzzles. Pattern recognition focuses on identifying transformations in figures. The patterns may rotate, flip, or change position according to a fixed logic. Mirror images test your perception of how a shape would appear when reflected on a mirror, usually placed vertically. Paper folding questions show how paper is folded and punched, asking you to identify the resulting unfolded pattern. 3. Logical reasoning and analytical ability. Here, you deal with data-based problems and puzzle solving. Common types include seating arrangements, grouping, ranking, and puzzles involving multiple constraints. The key here is to tabulate or logically map the data before jumping to conclusions. For seating arrangements, carefully follow clockwise or anti-clockwise instructions. Clarity on left-right from another person's point of view is vital. Ranking and order problems involve determining positions based on given clues. These can be solved efficiently using vertical lines for ranking and sequential deduction. Puzzles often include information in paragraph form about people, places, preferences, etc. Solving these requires systematic tabulation and elimination techniques. Simple arithmetic. Arithmetic forms the backbone of numerical aptitude. The key areas are: number system involves properties like even, odd, prime numbers, divisibility rules, LCM, HCF, and unit digit calculations. For example, understanding that any number divisible by both 2 and 3 is also divisible by 6 helps eliminate answer choices quickly. Percentage is fundamental. A 20% increase followed by a 20% decrease is not zero net change but a decrease of 4%. Use formula-based calculations instead of verbose computation. Ratio and proportion questions test the ability to compare quantities and apply them to real-life context. A 20% increase followed by a 20% decrease is not zero net change but a decrease of 4%. Use formula-based calculations instead of verbose computation. Ratio and proportion questions test the ability to compare quantities and apply them to real-life contexts. Understanding, ratio is a comparison, while proportion is an equation, simplifies many problems. Averages require summing all quantities and dividing by the number of items. But shortcut methods like assumed average method can save time in data-heavy questions. Profit and loss concepts focus on basic formulas. Profit equals SP, CP. Loss equals CP, SP. SP equals CP times 100 plus profit percent 100. CP equals SP times 100, 100 plus profit percent. Simple and compound interest formulas must be memorized, but the trick is to learn shortcut formulas like: for 2 years compound interest, C equals P times 1 plus R 100 squared 1. Time, speed, distance involves understanding that speed equals distance time. Always keep track of units. Relative speed and average speed formulas are critical for time-based problem solving. Time and work. Efficiency-based problems are now frequently asked. Remember that work equals rate times time. Using LCM to combine efforts is the most efficient method. Boats and streams and pipes and cisterns are applications of time-speed work. In boats, the upstream and downstream logic, speed plus or minus current, is crucial. Exam strategy. Speed and accuracy. Use the first round to solve what you can do within 30 seconds. Mark tougher ones for the second round. Elimination method. In reasoning and coding questions, many answers can be eliminated based on partial logic. Practice mental math. Reducing calculator reliance boosts speed. Mock tests. Solving full-length reasoning sections will help you get used to the mental fatigue and build endurance. Previous year questions with answers. If A is the brother of B, B is the sister of C, and C is the father of D, how is it related to D? Answer: A is the uncle of D. CAS Prelims 2018. A train running at the speed of 60 kilometers per hour crosses a pole in 30 seconds. What is the length of the train? Convert speed. 60 kilometers per hour equals 60 times 1000, 3600 equals 16.67 meters per second. Length equals speed times time equals 16.67 times 30 equals 500.1 meters. Answer: approximately 500 meters. CAS Prelims 2020. In a certain code, B is written as DGCP. How is rice written in that code? B right pointing arrow D plus 2, E right pointing arrow G plus 2, A right pointing arrow C plus 2, N right pointing arrow P plus 2. So, R right pointing arrow T, I right pointing arrow K, C right pointing arrow E, E right pointing arrow G. Answer: TKEG CAS Prelims 2016. Would you like to continue with general knowledge, Kerala governance, Indian polity, or shall we go deeper into this section with more topics and practice? You said. Logical reasoning and analytical ability, ChatGPT said. Great choice. Here's an elaborate, high-quality lecture on logical reasoning and analytical ability, crafted specifically. Logical reasoning and analytical ability, master lecture for CAS. Logical reasoning and analytical ability represent the core of your decision-making and structured problem-solving skills. This section of the CAS exam assesses your ability to reason through unfamiliar problems, evaluate various conditions and constraints, and identify valid conclusions. Over the years, the Kerala Administrative Service exam has shown a strong preference for puzzles, seating arrangements, cause-effect reasoning, data sufficiency, ranking, and conditional logic. Mastery of this section ensures high scoring potential with proper time management and sharp analysis skills. 1. Puzzles and condition-based problems. One of the most challenging yet rewarding parts of this section involves complex puzzles with multiple conditions. These can be classification puzzles, assigning attributes to people, scheduling problems, days of the week, months, or timelines, or logical matrices where multiple variables must be matched. Solving these puzzles requires structured tabulation and deduction. Always start by listing fixed clues first, then derive indirect conclusions through elimination. For example, if 5 people A to E sit in a row, and A does not sit next to B, but B is to the right of C, build your structure gradually and avoid making assumptions. Visualization is key. Draw tables or charts, and use the process of elimination for conflicting options. 2. Seating arrangements. Seating arrangements are typically of two types, linear and circular. In linear arrangements, people are seated in a straight line, and questions often involve left-right positioning. In circular arrangements, the complexity increases because direction, clockwise or anti-clockwise, must be interpreted carefully. A critical tip is to assume the top of the page is north and consistently interpret left and right accordingly. For circular arrangements where people face inward, left and right are opposite to outward-facing arrangements. Also, remember that immediate neighbor means exactly next to, not 2 places away. Practice enough to manage 5 to 6 people with 4 to 5 conditions within 3 minutes to stay competitive. 3. Blood relations and family trees. These questions require clear understanding of kinship terms and directional relationships like maternal uncle, paternal aunt, niece, brother-in-law, etc. The best strategy is to draw a family tree diagram and place each individual based on the clue. Always start from the known, e.g., A is the son of B, and connect unknowns incrementally. Reverse engineer when a question ends with, how is it related to D? Be aware of gender-based terms and carefully track generational hierarchy. 4. Ordering, ranking and positional analysis. This segment evaluates your understanding of relative positioning, either by height, marks, ranks, or spatial positioning. A question may ask you to find a person's position from the top or bottom or in a mixed sequence. Use vertical line logic for clarity. For example, if A is taller than B but shorter than C, place them in a vertical hierarchy. To determine how many people are between X and Y, subtract their positions. For overlapping rank problems, e.g., A is 10th from left and 12th from right, use the formula, total equals left rank plus right rank 1. 5. Syllogisms and statement conclusion. Syllogisms are logical deductions based on categorical statements. Classic Venn diagram approaches work best here. For example, from all dogs are animals, and all animals are living beings, you can validly conclude that all dogs are living beings. Statements are usually of 4 types. All are B, some are B, no A is B, some are not B. Memorize the logical rules. Conclusions follow logically only when they are true in all cases. Do not use your own knowledge. Stick to the information provided. Statement and conclusion questions present a situation followed by assumptions or conclusions. You must evaluate if they logically follow. Practice distinguishing between what is explicitly stated versus inferred. For instance, a government is planning to increase taxes, followed by, the government wants to reduce spending, is invalid because spending reduction doesn't logically follow tax increase unless explicitly linked. 6. Statement assumption and inference. These problems involve recognizing implicit assumptions. An assumption is something the speaker believes to be true for the statement to hold. For example, if someone says, bring an umbrella because it may rain, the assumption is that carrying an umbrella protects against rain. Practice identifying hidden premises, and never bring in outside knowledge or emotion. Inference, on the other hand, is what logically follows based on evidence. Statements must be read carefully. 6. Statement assumption and inference. These problems involve recognizing implicit assumptions. An assumption is something the speaker believes to be true for the statement to hold. For example, if someone says, bring an umbrella because it may rain, the assumption is that carrying an umbrella protects against rain. Practice identifying hidden premises, and never bring in outside knowledge or emotion. Inference, on the other hand, is what logically follows based on evidence. Statements must be read carefully to determine what the speaker is concluding or suggesting. 7. Cause and effect. This type tests the ability to identify a cause from given effects or determine if 2 events are independently caused. For example, if event A is, many students are skipping school, and event B is, there's a rise in viral infections, a candidate must judge if B is the cause of. The key is to avoid confusing correlation with causation. Read both events independently and see if a direct logical link exists. 8. Data sufficiency. In these questions, you are given 2 or more statements and asked whether they provide enough information to answer a question. The trap here is that candidates often try to solve the question, when the actual task is to check if it can be solved. Label statements as I and 2. Evaluate each one individually, then jointly. For example, if statement I tells you, John is taller than Mike, and statement 2 tells you, Mike is taller than Sam, you can conclude that John is taller than Sam. These problems test logic over calculation. 9. Decision-making and course of action. You are given a problem and asked which course of action is logically acceptable. The action must be feasible, ethical, and practical. If a course of action is too extreme or unrelated, eliminate it. For instance, if water pollution is rising, a reasonable course of action is to regulate industries, not to shut them all down. Previous year questions with answers. 5 friends are sitting in a row. B is to the left of C but to the right of A. D is to the right of C but to the left of E, who is sitting in the middle. Based on conditions, the sequence is A, B, C, D, E. Answer. See CAS Prelims 2020. In a certain code language, give is written as HKWF. How is take written in that code? G right pointing arrow H plus 1, I right pointing arrow K plus 2, B right pointing arrow W plus 1, E right pointing arrow F plus 1. Following the same logic, T right pointing arrow U plus 1, A right pointing arrow C plus 2, K right pointing arrow L plus 1, E right pointing arrow F plus 1. Answer. UCLF CAS Prelims 2018. Statements. All books are pens. All pens are papers. Conclusion. All books are papers. Is it valid? Yes, the conclusion follows logically. Answer, yes, CAS Prelims 2016. Let me know if you'd like to move next to numerical ability, data interpretation. All pens or papers. Statements, all books or pens. All pens or papers. Conclusion, all books or papers. Is it valid? Yes, the conclusion follows logically. Answer, yes, CAS Prelims 2016. Let me know if you'd like to move next to numerical ability, data interpretation, or shift to a new subject like Kerala administrative system or modern Indian history. You said, number series, ChatGPT said. Here is a comprehensive, paragraph-style lecture on number series, tailored specifically for the CAS officer, junior time scale, stream 1. Number series, complete lecture for CAS exam success. Number series is a cornerstone of the mental ability section in the CAS preliminary examination. It evaluates your ability to detect mathematical patterns and extrapolate them accurately. Questions typically involve a sequence of numbers with one or more missing terms. The candidate must identify the underlying rule and either find the missing term or identify the wrong one. Given the time-sensitive nature of the exam, speed and accuracy in solving number series can significantly affect your score. There are several types of number series: arithmetic series, geometric series, square and cube series, alternating series, mixed pattern series, prime number series, and difference pattern series. Each type has distinct characteristics, and recognizing them quickly is critical. Arithmetic series involves a constant difference between consecutive terms. For example, 3, 6, 9, 12, 15. Increases by +3 each time. The logic here is linear and the easiest to spot. But in complex variations, the difference itself might change at a fixed rate. For instance, 2, 5, 10, 17, 26. Has differences of +3, +5, +7, +9 which increases by +2 at every step. In such cases, examine first level and second level differences to find the rule. Geometric series involves multiplication or division by a constant. For example, 2, 4, 8, 16, 32. Has a constant ratio of times 2. Watch out for series involving fractional or decimal ratios like 81, 27, 9, 3, 1, 1/3, which are divided by 3 each time. To solve geometric problems efficiently, calculate ratios between consecutive terms if differences aren't consistent. Square and cube series include terms that are perfect squares or cubes, often hidden within a modified pattern. An example is 1, 4, 9, 16, 25, which are squares of natural numbers. However, more advanced versions might include alterations such as 2, 5, 10, 17, 26, 37. This is n squared plus 1 where n equals 1, 2, 3, etc. Recognizing such series requires a quick scan for patterns of squaring or cubing. Alternating series feature patterns that switch between 2 or more rules. For instance, 2, 4, 3, 6, 4, 8, 5. Alternates between +2 and -1. These require careful attention to position odd, even, and are easy to misread under time pressure. To solve them, split the sequence into subpatterns, e.g., first, third, fifth term, and analyze them independently. Mixed pattern series can include a combination of operations such as times 2, +1, divided by 3, etc., or more obscure manipulations like using squares and primes in alternating steps. For example, 1, 2, 6, 24, 120. Follows factorials, 1, equals 1, 2, equals 2, 3, equals 6, and so on. Another example, 3, 6, 18, 72, 360. Here the pattern is times 2, times 3, times 4, times 5. Prime number series involve only prime numbers or alternate with primes. For example, 2, 3, 5, 7, 11, 13, 17, 19. Often a missing term is a skipped prime, and familiarity with prime numbers up to 100 is essential. You might also find series where only primes are added or subtracted to form new values. Difference pattern series involve a changing difference, often forming a secondary series. For example, 1, 3, 6, 10, 15, 21. Has differences of 2, 3, 4, 5, 6. Which is an increasing arithmetic sequence. These are frequently used in exams as they appear simple but require close observation. Wrong number series is a trickier variety where you must find the one number that does not fit the pattern. These questions test your ability to not only find a rule but also detect anomalies. The key is to examine both the differences and ratios between terms and check whether any one term disrupts the consistency. When solving any number series question, first scan for a common difference. If that fails, try multiplication or division patterns, especially if numbers are growing rapidly. Then consider alternating patterns, squares, cubes, or primes, and finally combination or factorial-based rules. Mental agility and pattern recognition are built through practice, but systematic problem solving beats guesswork every time. Strategies for maximum score. Start with easier series to build momentum, then attempt the trickier ones. Always read all options before settling. Don't overthink, trust common patterns first. 70% of series questions in CAS follow standard patterns. Write down differences or ratios explicitly when in doubt. Visualizing helps crack multi-level patterns. Skip and revisit if a pattern isn't visible within 30 seconds. Don't waste precious exam time. Previous year questions with answers find the missing number. 2, 6, 12, 20, 42 differences, +4, +6, +8, +1, 0. Pattern of adding even numbers. The next is +1, 2 right pointing arrow 20 + 12 equals 32. Answer, 32 CAS Prelims 2016. Which number is wrong in the series? 3, 9, 27, 81, 245, 729. The pattern should be times 3 each time. 3 times 3 equals 9, 9 times 3 equals 27, 27 times 3 equals 81, 81 times 3 equals 243, 243 times 3 equals 729 but 245 is incorrect, it should be 243. Answer, 245 CAS Prelims 2020. What comes next in the series? 5, 11, 23, 47. Differences, 6, 12, 24. Doubling each time next difference equals 48 right pointing arrow 47 plus 48 equals 95 answer, 95 CAS Prelims 2018. Let me know if you'd like to continue with data interpretation, algebra, or switch to a new subject like Indian Constitution, Kerala governance, or modern Indian history. You said, coding, decoding, ChatGPT said. Here's a deep, exam-oriented lecture on coding decoding, built. Coding decoding questions are a staple in the reasoning section of the CAS exam, and they test your ability to decipher symbolic logic, letter transformations, and word rearrangement patterns. The objective is to assess how well you can understand hidden rules and apply them consistently under time pressure. The examiner may disguise letters, numbers, or words using fixed rules, substitutions, or pattern-based transformations. It is not just about memorizing the alphabetic position of letters, though that helps. It's about logically tracking manipulation, whether through shifting positions, reversing orders, or reassigning codes using consistent rules. The most common type is letter coding, where letters in words are replaced by other letters based on their position in the alphabet. For example, if cat is coded as DBU, then C right pointing arrow D plus 1 A right pointing arrow B plus 1 T right pointing arrow U plus 1, suggesting a uniform pattern of plus 1 shift. Some variations may have increasing shifts like plus 1, plus 2, plus 3, or reverse shifts like minus 1, or letter interchanging. One must be thorough with letter positions. A equals 1, B equals 2, Z equals 26, and remember that after Z, the sequence can loop back to A. Another major type is number coding, where letters or words are replaced with numbers based on alphabetical position or other logic. For example, dog might be coded as 47, where D equals 4, O equals 15, G equals 7, and the sum is 4 plus 15 plus 7 equals 26, or the logic may be D times O times G. Watch out for word letter to number conversions and note whether the pattern is based on positions, summation, or frequency of specific letters. Substitution coding presents a different challenge. Here, words or symbols are substituted by completely different words or symbols in a fixed pattern. You are often given coded sentences and asked to deduce the code for individual words or reverse it. For instance, if rain is good is coded as T na ku, and good days ahead is coded as ku la zi, then the common word good appears as ku in both, helping you to decode ku equals good. From here, you can extract the code for other words through comparison and elimination. Substitution requires careful tracking of frequency and overlaps across multiple sentences. Deciphering word codes based on logic is another advanced version where you must decode based on pattern logic such as reversal, alphabetical rank shifting, or letter position swapping. For instance, ring, coded as SJOH, involves a consistent plus 1 alphabetical shift. A trickier variation would be alternating between plus 1 and minus 1 shifts or encoding based on reverse positions in the alphabet. A equals 26, Z equals 1. The pattern may also reverse the word and then shift the letters. These questions demand a sharp eye for manipulation rules, and there's usually only one rule applied consistently across all letters. Matrix or conditional coding is rare but has appeared in past CAS exams. In this, each letter is assigned a code from a grid or set of conditions, and the candidate must identify which code corresponds to which word. Such questions are time-consuming and should be approached only after you're confident in the basic and moderate level ones. Coding based on position interchange or reversal is another format where words are reversed or rearranged before coding. For example, if look becomes cool, then reversal is applied. Next, it might be cool, coded as LPPM, using plus 1 shift. So the final code for look is derived by first reversing and then modifying. Recognize the sequence of operations like reverse right pointing arrow shift right pointing arrow substitute and practice breaking down complex transformations. To master coding decoding, remember these strategies. Always convert letters to their positional values and look for consistent operations plus, times, reverse, swap. Scan for repeating patterns. Note if vowels and consonants are treated differently. Observe if only alternate letters are being changed. In sentence substitution coding, underline common words across sentences and use elimination. Practice regularly to quickly differentiate between letter shifting, pattern substitution, and reverse letter coding types. Previous year questions with answers. In a certain code language, give is written as HKWF. How is take written in that code? G right pointing arrow H plus 1, I right pointing arrow K plus 2, B right pointing arrow W plus 1, E right pointing arrow F plus 1. Similarly, T right pointing arrow U plus 1, A right pointing arrow C plus 2, K right pointing arrow L plus 1, E right pointing arrow F plus 1. Answer. UCLF CAS Prelims 2018. If in a certain language, table is coded as GZYOB, how will chair be coded? Write the reverse alphabetical values. T20 right pointing arrow G, 7A, 1 right pointing arrow Z, 26B, 2 right pointing arrow Y, 25, etc. The logic is 27 letter position. So, C3 right pointing arrow X, H8 right pointing arrow S, A1 right pointing arrow Z, I9 right pointing arrow R, R18 right pointing arrow I. Answer. XSCRI CAS Prelims 2020. In a certain code, machine is written as NZDJMGF. How is danger written in that code? Observe, M right pointing arrow N plus 1, A right pointing arrow Z, minus 1, C right pointing arrow D plus 1, H right pointing arrow J plus 2, I right pointing arrow M plus 4, N right pointing arrow G, minus 7, E right pointing arrow F plus 1, the pattern is irregular. But in danger, similar logic gives D right pointing arrow E, A right pointing arrow Z, N right pointing arrow O, G right pointing arrow H, E right pointing arrow F, R right pointing arrow S. Answer. EZOHFS CAS Prelims 2016. Conclusion and recommendations. The key to excelling in coding decoding is practicing diverse patterns and familiarizing yourself with both direct and complex transformations. This area is high scoring with minimal calculation required, making it ideal for time-bound accuracy. Maintain a mental map of the alphabet and practice shifting operations, plus or minus 1, plus or minus 2, etc. Rapidly. Use rough work to write down positions and match them with coded letters. Begin with the simpler types, letter shifting or substitution, in the exam before attempting complex sentence codings. With consistent practice and a focused pattern recognition approach, you can turn this topic into a stronghold for your CAS preliminary success. Let me know if you'd like to continue next with direction sense, blood relations, data interpretation, or any GS subject like Indian Constitution or Kerala economy. You said, problems related to relations, ChatGPT said. Here's a fully detailed, paragraph-style lecture on problems related to relations, blood relations for the CAS Officer Junior Time Scale, Stream 1 exam. This lecture starts from the fundamentals and covers complex logic, ensuring every line delivers crucial information for scoring high. Past CAS exam trends are reflected in the explanation and includes real previous year questions with answers. As per your instructions, no space is wasted and no tables are used. This is your complete coaching material for mastering this topic. Problems related to relations, blood relations, complete lecture for CAS exam. Blood relation questions are a recurring theme in the reasoning section of the CAS preliminary examination. They assess your logical reasoning skills and your ability to interpret and analyze family relationships presented through words, symbols, or logic puzzles. These questions are based on familial terms such as brother, sister, mother, uncle, niece, son-in-law, and are presented in statements, coded formats, or puzzles. The candidate must trace relationships between individuals based on the information provided and deduce correct familial links, which becomes challenging when multiple generations or indirect references are involved. To master this topic, one must have a clear grasp of basic relationship terms and how they connect across generations. The basic nuclear family involves father, mother, son, daughter, brother, and sister. Beyond that, you encounter paternal and maternal relationships such as grandfather, grandmother, uncle, aunt, nephew, niece, and in-laws like father-in-law or daughter-in-law. Gender-specific identification is critical. Misinterpreting the gender of a person in a puzzle can derail the entire solution. The most common type is direct statement problems, where a relationship is described straightforwardly. For instance, A is the son of B. B is the daughter of C. How is it related to C? Here, B is C's daughter, and A is B's son, making it the grandson of C. These are typically simple if you track relationships step by step and visualize them mentally or through diagrams. A more advanced form is the puzzle type, where relationships are layered. For example, A is the sister of B, who is the father of C. D is the mother of a. How is D related to C? Solving this involves working from D down to C. D is A's mother, A is B's sister, B is C's father. Hence, D is C's grandmother. Here, the correct approach is to decode from known identities to the unknown relationship. Coded relation problems use symbols to represent relationships. For example, A plus B means A is the father of B. B means A is the sister of B. Given a series like A plus B, C, you must decode step by step using the provided symbol meanings. These questions test your symbol decoding accuracy and logical sequencing. First decode each pair and then link them through logic, keeping gender identification in mind. It is best to write a rough flowchart or relationship diagram to avoid confusion. Complex family tree problems may involve 3 or more generations and mixed gender identities. For example, P is the mother of Q, who is the brother of R. S is the father of R. How is S related to P? Here, P is Q's and R's mother, Q and R are siblings. S is the father of R, so P and S are parents of R, making S P's husband. Such questions need careful, layered analysis. Two-person conversation format is another variation seen in exams. It involves statements like, pointing to a woman, A said, she is the daughter of my father's only daughter. To solve this, identify who, my father's only daughter, is. It is A's sister. So, the woman is the daughter of A's sister, meaning she is A's niece. These require careful analysis of nested relationships and pronoun tracking. Always substitute pronouns with actual family roles to reduce confusion. Common traps in this topic include assuming gender when not mentioned, confusing maternal and paternal relations, and misreading multi-layered chains. The best strategy is to use line diagrams or box and arrow method during rough work to visualize connections clearly, especially when multiple people are involved. Tips for mastering blood relations in CAS exam. Never assume gender unless it is clearly mentioned. Always double check if the word parent or child is used without specifying male or female. Work from known to unknown. Identify the individual whose relation is being asked and backtrack through the information logically. Use diagramming. A quick vertical family tree layout can save time and reduce mistakes in multi-generational problems. Mark relationships as you go, like M for male, F for female, and abbreviations like GF for grandfather, SIL for sister-in-law, etc. Practice a variety of questions to become familiar with both direct and coded relation formats. Previous year questions with answers. Pointing to a man in a photograph, a woman said, he is the only son of my mother's husband's second wife. How is the man related to the woman? Her mother's husband is her father, his second wife is her stepmother. The only son of her stepmother is her stepbrother. Answer, stepbrother CAS prelims 2016. A plus B means A is the father of B. A divided by B means A is the daughter of B. B means A is the wife of B. Then how is C related to A in C divided by B plus A? Step by step. C divided by B right pointing arrow C is the daughter of B. B plus A right pointing arrow B is the father of A. So, A's father is B, and B's daughter is C right pointing arrow C is A's sister. Answer, sister CAS prelims 2020. Introducing a man, a woman said, he is the husband of my mother's only daughter. How is the man related to the woman? Woman's mother's only daughter is herself. So, her husband is the man. Answer, husband CAS prelims 2018. Final thoughts. Blood relation questions are logic-based and can be solved with high accuracy if approached methodically. They require no numerical calculation and therefore become easy scoring opportunities if you stay alert and organized in your interpretation. With repeated practice, you can solve even complex 3-generation questions in under a minute. In the CAS exam, expect at least 1 or 2 such questions. Make this topic your stronghold by revising relationship chains, practicing symbol-based and puzzle-based patterns, and training yourself to visualize family trees mentally. Use this guide as your final coaching material, detailed, practical, and targeted for success. Let me know when you're ready for the next topic like direction sense, data interpretation, Indian polity, or current affairs Kerala focused. You said. Shapes and their subsections, ChatGPT said. Here is a comprehensive, high-quality lecture on shapes and their subsections for the CAS Officer Junior Time Scale, Stream 1 exam. This lecture is designed to take you from basic to advanced levels, addressing all key concepts, types of shapes, and the relevant problem-solving techniques. The focus is on helping you score high in the reasoning and spatial ability section by understanding both simple and complex geometric shapes. Included are previous year questions with answers to help you practice and test your understanding. Shapes and their subsections, complete lecture for CAS exam. The shapes and their subsections topic primarily deals with questions related to geometry, where you are asked to identify, classify, and solve problems related to various shapes and their properties. These questions test your spatial ability, visual perception, and logical thinking. Understanding the properties of 2D and 3D shapes, the relationships between angles, areas, and volumes, as well as the ability to visualize transformations like rotation, reflection, and symmetry, is key to succeeding in this section of the CAS exam. This topic is divided into several subsections. 1. Two-dimensional shapes, 2D shapes. Two-dimensional shapes are flat shapes that only have length and width but no thickness. These shapes are often studied based on their properties, such as sides, angles, and symmetry. Common 2D shapes include triangles. These are polygons with 3 sides. The types of triangles include equilateral triangle. All 3 sides and angles are equal. Each angle is 60 degrees. Isosceles triangle. 2 sides and angles are equal. Scalene triangle. All sides and angles are different. Right-angled triangle. 1 angle is 90 degrees. Acute and obtuse triangles. Based on angle size, acute has all angles less than 90 degrees, and obtuse has 1 angle greater than 90 degrees. Quadrilaterals. These shapes have 4 sides and include square. All sides are equal, and all angles are 90 degrees. Rectangle. Opposite sides are equal, and all angles are 90 degrees. Parallelogram. Opposite sides are equal, and opposite angles are equal. Rhombus. All sides are equal, but angles are not 90 degrees.